Dear viewers, welcome to another video on Minitab tutorials. As part of Minitab tutorial series, we are seeing how we can use different tools, techniques and graphical representations available in Minitab. In this video, we will understand about a 3D scatter plot. Let's get into the video. So as I was explaining, a scatter plot is a graphical representation to understand the relationship between two continuous variables. So in your x and y axis, we will have continuous variables, and for that we will draw a scatter diagram or a scatter plot. So we have already done a detailed video on scatter plot. We have also done detailed video on matrix plot and various other graphs which are available to find relationship between two continuous variables. With x-axis one of the continuous variables and with y-axis one of the continuous variables. So I'll share the link of those videos in the description of this video. However, this particular graphical representation is a three-dimensional scatter plot. So if you see here, if I click on graph, I have an option which is called 3D scatter plot. So 3D scatter plot examines the relationship between a response variable in z-axis and two input or process variables in its x and y axis. So that is how a 3D scatter plot works. So to understand this 3D scatter plot, we are going to use an example where a process where metal plates are being done, and thickness of metal plate is my response parameter, and my input and process parameters are film density and vacuum pressure that I maintain in my process. Now here I select 3D scatter plot. So I select the first option, simple. So if you have the same 3D scatter plot, if you want to have it with groups, then you may have one more parameter, a categorical parameter in terms of thickness of metal plates done in plant A, plant B, machine A, machine B. Like that you can add categorical variables also to get into the fourth factor. But here we are going to do it with a simple three-dimensional scatter plot with one continuous response parameter and two input or process parameters. In this example, thickness as output metric, film density and vacuum pressure as my input and process parameters. So I select this and I click OK. So when I do this, I can select thickness as my output parameter in my z-axis. Film density will be one of my input parameters in my y-axis, and vacuum pressure is the next input parameter which will be in my x-axis. And now when I click OK, I get this kind of a three-dimensional graph. Now what does this three-dimensional graph represents? This three-dimensional graph is a indication. So as I was explaining in my previous videos also, this three-dimensional graph can be adjusted. So we can adjust this. So let's first try and get a better view of it. So I am adjusting it like this. So if you see this, there is some kind of a positive correlation, some kind of a negative correlation. Actually speaking, there is some kind of a negative correlation, because if you ignore the third dimension and look at the graphs only from a two-dimensional perspective. So here what I am doing is I am looking at the graph from a two-dimensional perspective. So if you see here, I have made it a complete two-dimensional graph. And if you see this complete two-dimensional graph between vacuum pressure and film density, they are thickness and vacuum pressure. If you see, there is kind of a negative correlation, because it starts from top left hand corner and comes down to bottom right hand corner. But that's not the intention of this three-dimensional graph. The intention of the three-dimensional graph is to understand all the three dimensions. So from that perspective, let's adjust this graph. Just a minute. Let's adjust this graph in such a way that we are able to make sense out of this graph. Just a minute. Right. So if I want to get a better thickness, my vacuum pressure is at this level and my film density is in this axis. So if you keep your mouse pointer on any of these parameters, you will understand how does your thickness changes with respect to vacuum pressure and film density. So the better, so if you are looking for higher thickness, so higher, then these are your optimized places where you have to maintain your film density. So if you are looking at this region, these are the places where, depending upon your vacuum pressure and film density, you will be able to get a better thickness as an output. So this is how you can understand how does this 3D scatter plot works. So similar to 3D scatter plot, if you want to understand how does your output variable, which is a continuous variable, and input variables, two input variables, and both the input variables are continuous variable, how can you use that particular data to examine the relationship? 3D scatter plot is a very good option, but there are other options also available, where I was explaining about contour plots, and I was also explaining about 3D surface plot response parameter, 3D surface plot. 3D surface plot and contour plots are two other ways by which the same data can be examined graphically. So I will share the link of those two videos also in this particular video. So hope this video was helpful for you to understand the relationship between a continuous output variable and two continuous input variables. So for similar videos about tools, techniques, graphical representations of Minitab, kindly subscribe to our channel. Thanks for your time. Thanks for watching.